All right, in section 410 in Trig, we're dealing with data that fits a sine wave or a cosine wave. Some patterns are not parabolic, they're not quadratic, they're not exponential, they're not linear like you're working on in your project. Some of them are actually sinusoidal. There's a $100 word for you. You can use that at parties, although it depends on what kind of strategy you're using on dating. If you're trying to keep them away, that's a good idea for now until you graduate college, and then you can pull out the words like sinusoidal. Anyway, in your calculator, you can enter all this data in. Notice that they have recorded on January 15th, which is the 15th day of the year, the number of hours of daylight. This is for Seattle, Washington. And so then they recorded the number of hours of daylight on February 15th, which is 46th day of the year, and it was 10.3 hours. And they continue to do that at different days throughout the year, always on the 15th of the month. And they recorded which day it was, and that's all listed in your textbook. You can find that on page 292. It's right before section 410. And so I went through my calculator and I entered all that information in my calculator. And there are, obviously, there are 12 different data points, obviously. Duh. My goodness, what's wrong with me? Obviously, it's time to go home. So anyway, I've got the data entered in my calculator. Let's take a look at the graph. We know how to set up a stat plot, okay, of the data. You know what, I better get rid of these equations from the last example that I did. So we want to turn one of them on, and we want to make it list 1 and list 2. Probably need to get a good window, so we're going to do zoom number 9. And obviously you can look at that and you can see that it's very sinusoidal. It looks like a sine wave. Now the high value and the low value here, we've got 8.48. You can hit the trace button and jump all the way over if you want to check, but it's 8.48 for the low value. And the high value would be 15.95. Now we know if we want to find the middle of that wave, the center line, we're going to have to average those two together. 15.95 plus 8.48. Okay, so average this together, and there is the middle of the wave, 12.215. So I want to draw that on my picture. You know what? I'm going to do a couple things here. One, I want to put 12.215. I think that's the right value. Let me just double check. 12.215, 12.215. Okay, good. I'm also going to change my plot a little bit. Instead of making just a plain old scatter plot, I'm going to switch it over to a line graph, because this is going to make it look a lot more like a sine wave. So I've put on the center line of the wave, and I've also changed it to a line graph where I'm connecting. So there's your line graph, and there's your center line through the wave. So we've got a couple different things that we know now. We've got the k value. You guys know the period of this function. It's 12 months, right? Or 365 days. Let me grab a piece of paper that I was going to use. So we know that the k value, 12.215, we figured that out by averaging the high and the low. Average of high and low. And we know the period of the function is 365 days. If that's the case, and we know that a is found by taking 2 pi times a is the period, then that means that a must be 2 pi over 365. Just doing a little bit of division. That's a fairly ugly looking scale change, but that's what it is. So now we've got those two pieces of information. I bet we can find the amplitude of the wave, right, by taking the high value, 15.95, and subtracting the center line of the wave, right? High value minus the center line. And so 15.95 minus 12.215. gives me 3.735. That's the value from the high to the center line. So amplitude 3.735. We know that that is the value of B. So far we almost have everything we need for our equation. Once we have our equation, oh, the last thing we need is H, right? We've got everything but H. So let me go back to my graph and see if we can figure out H. Suppose we wanted to make a sine wave. Well, guess what? I think H is going to be right there on the way up the hill, as we've talked about. If we were doing a cosine wave, I would pick it underneath the maximum. So I'm going to hit the trace button. And obviously being on the plot is not going to help me, so I'm going to use the up arrow, and it jumps me to the line for the center of the wave. And then I'm going to go over here, and yes, I am estimating, and I think, right about in there. So 83.93 is the value of H. Now suppose I choose 83.93, and some other person chooses 79.67 or something like that. You know, close enough, folks. Let's not get crazy here. So 83.93. If you want to average them together because you think that would be better, go for it. Okay. So H is approximated to be 83.93. Okay. Now we have everything we need. Y minus K, obviously 12.215, over B, which is 3.735, equals, we chose a sine function, over X minus H, 83.93, divided by A, which is 2 pi over 365. There's our equation, as nasty as that looks. In class, we're going to solve for y and we're going to solve for x. So in each situation, I can give you an x and you can give you an x and you can find a y, or give you a y and you can find an x. So we'll talk about those kind of problems in class.